All right, so we are doing the 2018 paper 2. Now, these solutions already exist online, but I'm still going to go through the paper and walk you through each and every question as best as I can. There will be things in here that some of you will know, some of you will not know, but that's okay. My job is to just make it as easy as possible. Now, this was the question we stopped at in the last class. We started this statistics question. I believe this was question 5. Now we move on to the next question, which is question 6. This one here was a measurement question. All right, so got quite a few persons this afternoon. All right, so remember, if you're from the CEP class, just bear in mind that there are things in this particular class that you may not know as yet, but you can still make notes and pay attention as possible. The paper was in the group chat, so I put it in the group chat for you, so you should be able to see it from there. Now, this question, question 6, is a measurement question. It says the diagram below, not drawn to scale, shows the cross section of a circular metal disc of radius 21 millimeters. A square hole with sides 6 millimeters is located at the center of the disc. Calculate the circumference of the disc. Anyone remembers the circumference formula? If you don't remember the formula, just remember that all the formulas are given at the front of the booklet. So if you go to the front page, the circumference formula is right here. 2 pi r is the circumference. 2 times pi times r. Okay, that is the circumference formula, in case you forget. So this first question should be fairly straightforward. 2 pi and r. The radius of the circle is 21. So you just use your calculators and work this out. Okay, so use the value of pi that is in your calculator. 2 times pi times 21 millimeters. And can someone give me the circumference of this circle? Okay, work it out for me. Tell me what you get in the chat, and we'll move on to part 2. All right, my exact answer is 131.95. If you round it up to 132, that is fine. Who's this person coming in? Let's see. All right. One more from the adult class. Okay, cool. So my answer is 131.95 and millimeters. If you want to approximate it to 132, go right ahead, but don't forget millimeters. Okay. All right. Now part 2, the area of the disc. We have, now remember, this disc is a circular disc, so you know you have to use the area of a circle formula, but you have this square part that was cut out of it. So if you have a part cut out, if you work out the area of this disc, you have to remember to cut out that circular part. Okay, so it would be the circle minus the square part on the inside. Okay, so that is how you would try to work out this area. Now I'm gonna let y'all work this out. If you haven't done it already, try to do so. The area of a circle is the formula pi times radius squared, and the area of a circle, you know, is just whatever length you're given, just square it. Okay, so that would be the two formulas, and I'm gonna pop back in. You guys tell me what the area of the cross section is. Okay, what is the area of the cross section of this disc? By the way, Omara and Keandra and Jayla, just because there are some people in here you don't know, I still want to hear some voices. So I want persons to talk to me while I'm in here. You know, when they call on you, we can still have our usual conversation. Somebody's trying to come in, but I'm not certain who that person is. Anyway, I have one answer in the chat so far. I'm looking for some more confirmation. Anyone else has something similar to what Omara has? All right, here we have Imhotep. We have some more people from my fifth form class joining too, so that's good. All right, cool. All right. Anyone has an answer besides Omara? All right, so looking at the chat, we have two answers here. So again, the area of the circle is just going to be pi multiplied by the radius, which is 21 millimeters squared. You should be able to put that straight in your calculator, and the answer for the circle's area should be 1385.44. If done correctly, of course, you can round it up to the nearest whole number if possible, millimeters squared. And now let's work out the area of the square. So again, that is just 6 millimeters all squared. So that would be 36 millimeters squared. And of course, if I subtract these two numbers from each other, I should get what Omara and Tiron have in the group chat. 1,349.44 millimeters squared. Okay, so that is my answer for that one. Okay, so very good. All right, so the next question. Given that the thickness of the disc is 2 millimeters, calculate the maximum number of discs that can be constructed from 100 centimeters cube if available. And they have a conversion here that says 1 centimeter cube is 1,000 millimeters. So how many discs can we Right, Omara, 22 over 7. Nope, I'm using the straight pi button in my calculator, okay? So I'm not using, if the question says use 22 over 7, then yes, it did say to use it up top here. So most of these answers should be whole numbers if you did it correctly. It did say use 22 over 7. It's just that I can see it on my screen. So yes, your answers are probably the more correct answers. So your answers from before, the 1,350 is probably correct. But in most cases, I just use the pi straight from my calculator. But you're correct, Omara. Just I can see it's just that I couldn't see the instruction up top here because my is blocked from my on my screen. But you're supposed to use 22 over 7 for these questions. All right. So that being said, let's go on to part 3. So let me just fix the answers up here just to make sure that everyone has the correct answer. So the correct answer for the first one is just the 132. If you use 22 over 7 for pi, this is the correct answer here. And if you use the correct pi for this working down here, then you should have gotten what Omara got in the chat. So that answer there should have been 1,386 millimeters squared. And the direct answer then would have been 1,350 millimeters squared. Okay, so I just did the corrections there for those that came in, but you were supposed to use pi as 22/7 for this question. But in most cases, we just use the pi button that is on our calculator. So, but it's just that this question had a restriction. Anyway, what is the answer for part 3? Anyone has an answer for the part 3? How many discs can you get if you are, how many discs? Yes, Joseph. So your question is the 1,349.44. Technically, it would be a mark off because they did say to use pi as 22/7. So I will have to agree and say yes, they did say so in the instruction. However, you definitely will not get 0 because the answer is still correct. But they did say use 22/7 in the question. So you always follow what they say. All right. So next question. Anyone worked out the other one? Part 3. Not yet. All right, let me assist you with the logic in this question. So remember volume. Volume is always V for volume is always cross-sectional area. Cross-sectional area multiplied by some other unit, in this case thickness. So you would multiply by the 2 millimeters. Okay, that is how you work out volume. Now you need to work out the volume of one disc, and then one and only then you could then find out how many discs you can construct. Okay, so I'm hoping people can get this one out. All right, so I'm not hearing anyone for this one. Are you still working it out, or we need some assistance? Just talk to me. Let me know if you want me to just jump in, or are you still working it out, people?
This will come in liters, or wait, I trying to see the thing.
Right? Can I see it so clearly?
Zoom in some. Let me
See
zoom
if
in
I can.
some more.
All right, I zoom in a little bit here for you, so hopefully you can see it now a little better.
I get
All right. So
0.68
mhm,
because I rounded off to the next
0.68.
yeah, around the next sufficient figure.
That's not the correct answer for this one. All right. So let me jump in here. I see someone just joined. Let me see who that person is. All right. Cool. All right. So again, you have some disc. These discs are 2 millimeters thick. So the first thing you want to do is work out the volume. So I'm going to put V over here. Volume would be the area that we worked out before, the cross-sectional area, which is the 1,350 millimeters squared, multiplied by the thickness, which is the 2 millimeters that we have in the question, okay? So let's work out the volume of one disk first. What is the volume of one disk? Can someone do this calculation for me? Multiply it by 2. What's the volume of one disk? All right, 2,700, 2,700 millimeters cubed. That is the volume of one disk. Now, the goal is to figure out how many disks we can make. The question said that the sheet of metal, we have the Quan joining. Let's see if the Quan can come in. The sheet of metal is 1,000 centimeters cube thick, but notice that my units are not in centimeters cube. Okay, so my units are not in centimeters cube, they're in meters cube, but it did give me a conversion down below. So what I'm going to do is I'm going to convert this 1,000 centimeters cube into millimeters cube. Now, what was the conversion down here? The conversion was 1 to 1,000. So it means that you have to multiply by 1,000. So what is 1,000 centimeters cube multiplied by 1,000? Okay, this will give me the answer in millimeters cube. What is that big number that you would get? 1,000 by 1,000 is how much?
A million?
1,000 by 1,000 is a million. 1 with 6 zeros behind it. Okay. And this is the amount of millimeter cube that I have to work with. And remember, I worked out for one disk. This is one disk up here. I worked out the volume for one disk. Now, to find out how many disks I can get from this sheet of metal, I would have to divide this by the same 2,700 millimeters cube that I had from before. All right, so that's all it is. Okay, so remember 6 zeros. Yes, you missed a zero, Joseph. 6 zeros is a million. Okay, 1 and 6 zeros. All right, so how many discs can I make? Okay, so the question should be I should be able to make 370 discs. All right, so just remember, just so you can visualize the problem, it is a sheet of metal, probably in some kind of cylindrical form, and I got some machine that cutting these discs off all the time. So each time the machine makes a cut, it forms a new disc, and I can get 370 discs from that clump of metal on that machine. Okay, that's basically what this question is saying. Now, do you all understand? Does it make sense? Give me a thumbs up if you understand. Um, of course, measurement questions are always there for us to practice. We got to go through some more of them over time. All right. All right, good. So Omar, I now can see the instructions here up top here. So yes, you were 100% correct. you had to use pi as 22 over 7. All right, so moving on, next question. So, what length of string would represent an actual distance of, I think I'm probably missing a part of it or so. Let's see if I'm missing. I'm thinking I'm probably missing a part of this question. Let me pull up the actual paper and see. All right, so this question here is another measurement question. For this question here, it says a globe is a scaled spherical representation of the Earth. The actual length of the equator is 40,000 kilometers and is represented on the globe by a piece of string of length 160 centimeters. So as I highlighted before, there is a relationship between that 40,000 and that 160 centimeters. So we want to know what length of string would represent an actual distance of 500 kilometers on the globe. I was saying that back in the day, we had lots of questions that involved the equator and the globe and longitude and latitude. Those questions are gone. They're no longer part of the syllabus, but this is still a measurement question here. So you have a relationship between that 40,000 kilometers and that 160 centimeters of string. Now, I would recommend you find what 1 kilometer would represent on the string. And once you know what 1 kilometer would represent, then you could find out how many 500 kilometers could represent. So this is what we call unitary method. Um, I'm going to see if anyone has this answer or can work it out. So I'll check the chat in a couple of minutes and see if you can figure out the answer. But the relationship is 40,000 kilometers represents 160 centimeters. It is in your best interest to find out what 1 kilometer should represent as a piece of string and then multiply that by 500. All right, so I'll see you in a few minutes. See if anyone has this answer. I'll pop back in and we'll go from there. Jayla, Keandra, you have an answer for this one? Omara? 2? All right, let's have a look here. So, unitary method. If you remember this from primary school, you find out what 1 represents, and then you can use that to solve any question. So, over here it says, if the 40,000 kilometers is equal to 160 centimeters, what I can do is I can, if I want 1 kilometer, I had to divide this by 40,000. Okay, to get from 40,000 to 1, you have to divide. So I divided by 40,000. So likewise, I must do the same thing on this side here. I must divide by the equivalent 40,000. So I can just simply put it like this. 160 over 40,000. Now to get 500 kilometers, I would have to multiply by 500. So 500 kilometers equals, and I will write back what I have before, 160 over a 40,000. All right, and if I'll multiply this now by the 500, and that will give me my answer. Okay, so if you do this correctly, you should get the answer of 2 centimeters. 2 centimeters worth of string. Okay, so that is the answer for that. 2 centimeters worth of string represents 500 kilometers on the actual globe. Okay, 2 centimeters worth of string represents 500 kilometers on the globe. I'm hoping that makes sense to most of you. I did all these diagrams and arrows are unnecessary in the exam. I just did that to show you what was going on, but it's unitary method. You find out what 1 kilometer is represented by, and then you just multiply by the 500. All right, so next question. The distance between these two places is represented on the globe by a string of length 25 centimeters. Calculate the value of PQ, the actual distance in kilometers. So that's straightforward. If you got the answer, if you understood this answer here, then this answer is even more straightforward. So what answer do you all have for this? Keandra, you want to share how you got your answer for me, please? If you care to, I want to know how you got that answer. It is right, by the way. Just want to know how you got it. All right. Okay, go 2 centimeters is 500 kilometers. And I guess you work from there, the same unitary method to get the answer. I know you might work in Canada, so stop playing shy and you could turn on, you might when you're ready, you know. It's okay to talk. I know you got people in here don't know, but don't be ashamed. All right, so let's go. She is correct. Um, if well, this is how I figured you could work it out. There always more than one way you can answer it. If 2 centimeters is equal to the 500 kilometers, 1 centimeter would be equal to 250 kilometers. And if I know what 1 centimeter equals, then I can simply multiply that by 25. So I can say, therefore, 25 centimeters would be equal to 250 kilometers multiplied by 25. All right. And the answer is 6,225, 250, sorry, kilometers. All right, so that is the correct answer. All right, good job for those that worked it out. Now, moving on to the next question swiftly. Now, this is one of those pattern questions. Let me zoom out a little bit so you guys can see. Okay, so you have these 3 shapes here, and your goal is to represent the 4th shape in this sequence. So this is probably the easiest mark you can get in the exam, depending on how hard the drawing is. I've seen some years with some very easy drawings, and then some other years with some ridiculously complicated drawings. But in any case, this one is not difficult, in my opinion. I'm hoping persons did it, and and you can have the shape. Now, for me, I'm just gonna make my life easy. I am just going to copy this. I mean, you guys have to draw it by scratch, but I'm going to copy this, and I'm just going to add on the extra 2 layers that I am supposed to. Okay, of course. So you just draw one, just draw in a block here, and a block here. Is that what y'all have? Easy stuff. All right, next one. Now, this is one of those sequence problems. Of course, the 2 questions are related. This question and this question are related, but we don't really have to look back at the diagram to answer this. Okay, we don't have to. All right, so let's look at the question in its entirety. You have a table, and you want to figure out the pattern, and eventually you want a general formula. You want a general formula to help us out. Okay, so let's go. So the only ones to answer would be this one here, next number in the sequence, the perimeter of the shape, and then you have to, I would recommend you do this one here second, get the general formula, and then you can go back up and work out this one here. Okay, that's how I would possibly do it. All right, so we have the Daquan saying that this one here is 9. And this one here is 20. Now, at this stage, what you should do is try to figure out what is the common difference between these terms. What number must I add going down to the next number? Okay, what number is it? Anyone could tell me what the common difference here is for over here on the right? The common difference is 2. So I'm adding 2. I'm adding 2 each time. Okay, good. So whenever you are trying to find the formula, remember this common difference goes in front. So this goes in front, 2n. All right. And the last part of the formula is the difference between this number and that number. 3 is 1 bigger than 2. So that means it will be plus 1 at the end. Okay, so this is a formula to work out all of these here. Now let's prove that it works. 2 times if n is 1 plus 1, that gives me 3. 2 times 2 plus 1 is 5. So my formula works, okay? See if you do the same thing on the other side. Work out a formula for the perimeter. Do the same steps to see if you can work out a formula for the perimeter down here, okay? So let's see if we can work out this formula down here. Start with the common difference. Start with the common difference between the terms. And go from there, people. And you should be able to work out your formula. Once you find that common difference, remember it goes in front the n, and then you figure out what the remaining part is. So just tell me what the common difference is, and then we'll work out the formula. All right, so Jayla says the common difference is 4. So 4 is going to go here. And if the common difference is 4, what's the difference between 8 and 4? The difference between 8 and 4. All right, so Amara has the full formula, 4n plus 4. We can always double check here on this right side. So 4 times 1 plus 4, that's 8. 4 times 2 plus 4, that's 12. So our formula checks out. So we have both formulas here. All right. So that is how you usually solve these questions. Now, this last one down here was a little challenging. Even people that did the solutions online said this question here was a little challenging. Determine the relationship between the number of squares and the perimeter P of the figure. All right. This one I think was only worth like 1 or 2 marks, but you can try to figure it out. If not, we'll come back to it. Okay. All right, so I'm gonna have to move on, but again, we want some kind of relationship that is gonna map or that it will relate the 2n plus 1 onto this 4n plus 4. All right, and oh, Keandra wants me to do it. All right, no problem. Let's see if I can figure it out. Give me a minute. All right, so from all I can see here is that to get from this term to that term, it seems as though I multiply this first term here by 2. And let me see, trying to figure it out. I'm not certain for this one, but I know that it involves some kind of multiplication by 2 to get this. Okay, yeah. So I think I figured it out now. Okay, so if I take this formula here and I multiply it by 2, so that will be, I will get 4n plus 2. Now I would then have to add 2 to get 4n plus 4. So it involves multiplying by 2 and adding 2. So if I want it in terms of s, I will say that it is 2 times the number, 2 times this formula. This formula here represents squares. This is s. This formula here represents p, the perimeter. So to get from squares to perimeter, the relationship is 2 times s. And then I have to add 2 onto it so I can get the 4 here that was in the perimeter. So this is the formula for this one here. 2 times, so to get from squares to perimeter, I have to multiply this square formula by 2 and then add 2. Okay, let's see if it works. Let's see if it works out up here. Let's try the 7. So 2 times 7 plus 2 is 16. So it does work out. Okay, does that make sense to you? It's a weird question. I didn't like it, but is what they threw at what they threw at us in that year. Okay, so to get from that formula to that formula, it was a matter of multiplying by 2 and adding 2 to get the answer. So does it make a little more sense or not quite? Give me a thumbs up if you kind of understand it or not. All right, cool. All right, moving on smartly. Here we have one of those plotting questions. We have, now this function here is not the common function that we would have seen. It's not a quadratic function. It's not a linear function. This function is called a reciprocal function. So when you have a reciprocal function, just bear in mind the graph is neither straight nor it is curved. The graph actually looks a little weird. Now this graph, the graphs of reciprocal functions usually have some kind of weird curve going on like this, but we'll see what the graph is when we get to plot it. Okay, and I think the question did give us half the graph drawn. Okay, I skipped the question, Omara.
Yes, sir.
Which one did I skip? Which one did I skip? Oh, you mean this one, 43? Now we can work backwards and find that. Okay, sorry about that. So we know that 43 is the number of squares. So we could use our newfound formula and put in 43. So we can do 2 bracket, put in the same 43, close bracket, and then add on the 2, because we worked out a formula just below here to map this onto this. So what would the answer be? Anyone has an answer for me? The answer is actually 88. Okay, so that answer is 88. All right. And the number over here, that is supposed to be in this column here, can be found by just using this formula here. So I can say that 2n plus 1 is supposed to be the 43. And if I work backwards, 2n would be equal to 40, will be equal to 42, and n would have to be equal to 21. So this answer here is 21. Okay, so I have 21 and 88 as the two answers there. Thank you, Omara, for pointing that out to me that I missed that question. All right, so let's fill in this table here.
Yes, sir. Will you add 2 and C?
So which one?
C.
Okay, so look. So remember, you had 2n plus 1. If you multiply that whole equation as Keandra, that asking me?
Yes, sir.
If you multiply that equation by 2, tell me what you get. 2n plus 1 multiplied that by 2. What would you get?
4n plus 2.
And we need another 2 added on to get to 4. So that's what you had to add on the 2. Okay? So it becomes 4n plus 2. And then you had to add on that 2 to make it 4. So it matches with the other equation over here on the right. You understand?
Yes, sir.
All right. It was a weird question. If you didn't understand, to be honest, it was a weird question, but we were able to get through with it just now. All right, so moving on. Let's look at this function here. So you're given a function. Remember, f of x is representation for functions or y. And you have 3x plus 1 over x. Now you are plugging this value in the function and you're plugging that value in the function separately. So the first value is f of 0.5. That will be 3 bracket 0.5 plus 1 over 0.5. Okay, so you just use your calculators and solve that. I think Jayla has the answer in the chat already. So the answer is 3.5 here for the first one. And for those that still needed a little extra help, let me do the second one, f of 2. You're plugging in 2 into the function. Three times 2 plus 1 over 2. And the answer, if done correctly, the answer is 6.5. And that goes in the table here. Okay, so these are the coordinates that you plot for your graph, the x and y values. Now, they were gracious enough to plot almost all the graph for us already. So on the next page, you might see, I don't know if you all have loose graph paper at home, but this is the graph that I have, as in this is what CSEC provided for us. And our goal is to fill in the 2 little points that we're missing. So this is the easiest graph to do because they plot almost all the points for you. It's just you have to fill in 2 points. Now, of course, if you've never seen this kind of graph before, you might be wondering what am I really drawing? But really and truly, it's not a hard graph to understand. You just fill in the points now. So the first one is 0.5 and 3.5. So I come across to 0.5 on the x-axis. So let's see where 0.5 would be. So this is 1, 2, 3, 4, 5. So can someone work out for me what each of these little baby squares, each of these squares in here represent? What would each of these squares here represent? If there are 5 lines going across, what would each of these squares represent?
A centimeter?
I mean, the squares are a centimeter, but I mean in terms of plotting the graph, because you've got a scale of 0 to 1 and 5 squares in between. 5, 1, 2, 3, 4, 5 lines in between. I want to know what each of these lines will represent. So if it is, so to work out the scale, since it is 0 to 1, I put 1 divided by 5, and that means each line that coming down here represents 0.2. So each line here represents 0.2. Let me zoom in a little bit so you can see. Each of these solid lines coming down represents 0.2. So if that's 0.2, this one here is 0.4. This one here will be 0.6. This is 0.8. And it goes to 1. So 1, 0, 0.2, 0.4, 0.6, 0.8, 0.1. So therefore, the halfway point between 0.4 and 0.6 is 0.5. All right, so the first coordinate was 0.5, 0.5, and coming up to 3.5. So 3.5 this is 3.5. And 0.5, let me get my ruler. Is right between 0.4 and 0.6. So it's actually in this open space right here. Okay, so let me just see. All right, so it's actually right here going up. So this is 0.5. And I will stop right here. So I don't have to draw the line, but I just wanted to show you guys where it would be. So it is actually right here. Remove the ruler. This is where the coordinate here will be. Okay, so it looks a little odd, but it is right here. All right, now the next one is at 2 and 6.5. That one is a lot easier to plot. So come across to 2, come up to 6.5, which is right here. A nice, easy coordinate. You can want an easier graph to plot in the exam. It's just that it looks weird. But looking weird doesn't mean it's not easy to plot. So now I have the 2 points drawn in. My goal now is to draw a smooth curve through these points. Now this is going to be ridiculously hard, granted that I am on a computer, but for you all who may have the paper in hand, try your best to draw a smooth curve that comes through the points. So this is a weird looking graph. It is a reciprocal function graph. Those normally look weird, but this is what it should look like, okay? So that is the graph itself, and always extend your line past the last point. All right, but you try to make your curve as smooth as possible. Because I'm on the computer, I can't draw it as smoothly as I would like. That's not as smooth as it should be, but I think I should still get some marks at least. All right. I will try to make it a little better. I would recommend you try to make it a little better on your graph. Okay. So the next question, if I go back, it says, by drawing the appropriate straight line, find the solutions for when the graph equals to 6. When the graph equals to 6. Okay, so this is a case where when you have your graph, what you will do, you take your ruler and you draw a line across from 6. Let me put it in blue. You draw a line across from 6, and it should go straight across. I'll come up a little more. And it should cut the graph at 2 points. Okay, so this line going across cuts this graph at 2 points. Okay, so the first point that it touched, I want to know the corresponding x value for that point. So it cut the graph here, and I will draw a straight line coming down and try to figure out what that x value is. Of course, using a ruler is essential for this. And of course, I will come across now, and I want to find this x value as well here too, coming down. But use a ruler if you can. You should always have a ruler for your exams anyway, so make sure you have 2 rulers. All right, so the 2 answers that I see, if I zoom in down here at the bottom, I know mine is a little bit off, but for this point right here, that looks like 1.8. So the first x value here, if I zoom in even more, this one down here looks like 0.2, 0.4, that's 1.8. And the value over here, it looks a little bit less than the 0.2. Let me see if I can work out what each of those little baby squares would be. So 0.0, 0.2 divided by 5. Each of those baby squares is 0.04. So let me see. 1, 2, 3. So this x value here is a little bit less than the and the 0.02, I get 0.12. But of course, your graphs may be different. My graph was not as accurate, especially in this curve part here. So who knows? It could very well be like 0.16 or 0.1 something else. Okay, but my that is what I got. Okay. It could be about 0.16, but I got about 0.12. But it depends on how well you draw your graph at this particular part. But CSC will still look at it and say, well, look, you did everything else correct. And depending on how off it is, you might still get the mark. Okay? Everyone understands? For those that never saw this function before, it might be a little different for you. All right, moving on slowly but surely. Here we have a speed, distance, time graph. Show of hands, those that did speed, distance, and time before. Anyone did that before? All right, Elliot. Okay, cool. All right, I'll leave it here. Most people in here, Jilla and Omar, did you all do speed, distance, and time yet, or not quite?
Sir, we didn't interfere, but I can't remember what is it.
Did it in third form? Nice. I don't know what you're talking about.
Sir, we do this before.
We do this in third form?
We do speed, this was on time.
No, sir. I do not remember this.
Nah, we ain't do this in third form, Jilla. We ain't do this in third form. We definitely did. We probably did the formula, but we don't think we did this graph in third form. But anyway, let me walk you through it here as best as I can. I do this with my fifth formers. They would have did this last term, in the middle of last term. And I believe if Mr. Relly gets the time, he would do it with you all, or he should have done it with you all in the duplication session or whatever. Okay, but this is speed, distance, and time. Now, this graph is a speed versus time graph. Let's look at the question. It usually represents the motion of an object. In this case, it is a car that is traveling. It is traveling with some speed. If the speed is increasing, that means the car is accelerating. And as you can see here, it's accelerating slowly here and then rapidly here. Like if the guy now reached the highway and he starts speeding in this region here. Okay. Now, with these graphs, you can work out the speed at a particular point, as well as the distance traveled over a period of time. So let's examine how to do this question here. All right, just give me a minute. All right, so with this question here, let's calculate the acceleration in stage B. Acceleration A is equal to the change in speed.
Divided by time.
Change in speed divided by time. Now, another way of thinking of it is the gradient of this line. Okay, so the gradient. So remember the whole gradient equation. We put T2 minus T1. This is the same thing as the gradient equation. Remember, Y2 minus Y1 over X2 minus X1. So you just have to find the gradient of this line here, okay? The gradient of that line. So you take the 2 points that are known. Let's tell me the coordinates for this point up top here. So I want to tell me the coordinates for this point up here. What's the coordinates for that top point? And then what's the coordinates for this bottom point down here? Tell me those coordinates quickly.
These points can be random or just a
No,
specific
the
area.
points that are given here. These points here are usually points that are given in the question. You could choose other points, but use the points that are given in the question. I just want the coordinates of these 2 points. Tell me them quickly or put them in the chat for me. So you know you gotta read it as X and Y, 2X and Y points. Come on, people, don't stick up. How to read a point from a graph. What's the first coordinate there? Don't. What's the first coordinate? Don't hear. X first, then Y.
So 40, 15.
Yeah, 40, 15. Don't take forever to do that. 40, comma 15. All
Then
right,
60, 40.
and 60, 40. All right, 60, 40. Now, of course, we find the gradient of this. This is the acceleration. So you just plug in the values. Y2 is the 40. So Y2, remember this is X1. So it is X2, Y2. And this one here is X1 and Y1. So it is 40 meters per second minus the Y2, which is 15 meters per second, over. Can someone tell me verbally what the bottom part should be? What should
60
the bottom of
seconds minus 40 seconds.
All right, 60 seconds minus 40 seconds. Jill, I think you did this with Mr. Devonish, you know. You sure you did this with physics?
Probably. Yeah, I think
Uh-huh.
so.
Yes. So, what is the acceleration in stage B? Can someone tell me? Is it the two decimal places? What is the acceleration in stage B?
1.25.
Correct. 1.25. And the unit is meters per second squared, because you divide by second again, it goes down, it goes to per second squared. So you put -2 instead of -1 in that. Okay, so it's just the gradient. The acceleration is the gradient of the line. Okay, now the next question: the average speed. The average speed for this in stage B as well, the average speed in stage B. Now remember, average speed is equal to total distance in stage B, total distance divided by the total time. Now they only want stage B itself. So to find the total distance of stage B, what you will do, then it says stage A, it says stage B. So you have to find the area under stage B. The area under stage B. And to work out this area, remember it is a trapezium. Okay, so you work out the area of this trapezium. The area under the graph is the distance covered. For those that didn't know, you could put a little note here. Area under the graph. Area under the graph equals the distance covered. Okay, so we need to work out the area of this trapezium. Anyone remembers how to work out the area of a trapezium? If you say no, to be honest, if you don't remember, you don't remember. Yes or no?
Have A plus B in brackets H.
It's correct. That's correct. Now, if you really forget, always go back to the front of the paper and look. It should be somewhere up in here. Okay, so the trapezium formula is usually at the front, on the front page somewhere. It's right here. See, half A plus B times H, where H is the height of the that is perpendicular to the two parallel sides. So let's go back to the question. So this trapezium here, the two parallel sides will be here and here. So I am going to say that the two parallel sides are, this distance here is 15 meters per second, and this distance up here is 40 meters per second. So I have the two parallel sides divided by 2 and then multiply by the perpendicular side. Now the perpendicular side is actually down here because this trapezium is on the side. This down here is the perpendicular side to the two parallel lines. So what's this distance from here to here? If someone tell me what that distance is from 40 to 60. 40 to 60 is how many seconds? Or the 60 is how many seconds, people? Right, 20 seconds. All right, so I'm going to multiply this here by the 20 now. So 20 seconds. And notice that the seconds will cancel, the per second and the second will cancel out. So when you work this out, these two will cancel with this. Okay. And what is the answer in meters? Can someone tell me the answer in meters? 15 plus 40 divided by 2 multiplied by 20. What is the distance covered? And someone tell me the distance covered. 550 meters. Now, again, our goal is to work out the average speed. So our goal is still to work out this divided by the total time. So the total distance divided by the total time that it took in stage B. So 550 divided by the same 20. To me, that is going to go back, basically going back to what we worked out before, what we had before, which is 27.5 meters per second. That is the average speed that he took. Okay, but remember this was the answer for the distance. This is the answer for the total distance, and this 20 came from down here. Okay, total distance over the total time it took to get from that point to that point. All right, so the answer is 27.5 meters squared. Sorry, 27.5 meters per second. All right, so this question here, if you haven't done these questions before, then we got to practice some more of these, possibly come tomorrow. Jayla and Omara, we got to practice some more of these if you haven't done them before. All right, so next question. Next question. Okay, so this one
No
was a bit,
question, sir. So you
yes,
meeting tomorrow again?
not online. I mean at school. So
Okay.
I got class with Jayla, Keandra, and stuff at school. So I'll go through some more of these here. But I probably wouldn't do any more online classes for a little while. I had one this morning, and I have one now. So Mr. Small is completely tired. That's 4 hours online already so far for the day. So I'm a little tired right now. So I apologize for all any mistakes that I made, but that's because I'm tired. Anyway, moving on to the next question. It says here at, sorry, I gotta zoom in a little bit, it's a little fadey. At the time t equals to 60 seconds, the car starts to slow down with a uniform deceleration of 2.5 meters per second. How long will it take the car to come to a rest? So, how long will it take the car to come to rest? All right, so let's see. If acceleration is equal to speed, speed divided by time, then if I want to find time, then all I have to do is rearrange this equation. So time will be equal to speed divided by acceleration. All right, so let's see. Uh, deceleration. So it says, yeah, so the deceleration is 2.5 and it slows down until it comes to a rest. So it's basically you are going from 40 to 0. So you are here at 40 and you're pressing the brakes and you are going to 0. So you are essentially going from 40 to 0. So if your speed was 40 meters per second at that point in time, and you are decelerating at a rate of 2.5 meters per second squared, then eventually you will come to rest or the car will slow down in 16 seconds. Okay, so that is that question. So again, at this stage here, it was traveling at this speed here, 40 meters per second. Okay, and it says it's slowing down 2 meters per second squared, and it should take 16 seconds for it to come to rest. Again, if you don't quite understand, that's okay. We have to go through some more of these questions. All right, but show of hands if you have a little bit better understanding now, or if you think you want to practice some more of these, I will provide some more of these here for you. All right, we're about halfway through. We are at this bearings question. Now, bearings is an extension of trigonometry. Okay, it involves a little geometry as well. So I'm hoping everyone in here knows their cosine rule as well as their sine rule to answer these questions. Now, the first one actually might be straightforward. It says determine the bearing B from F. Whenever it says from, that is the starting point. So before you do anything, you should probably draw a north line at F because all bearings always start from the north line. Just like how you see over here on just like how you see over there on the left, there's always a north line involved with bearing. So you have a north line here, and you should also draw in a north line at F as well, because bearings always start from the north line. All right. So this is my north line here. Now, the bearing of B from F is the distance all the way around here going clockwise. The bearing is always clockwise, so it's always going to the right. Now, is there a way to work out the bearing of B from F? There is an easy way and there's a hard way and there's an easy way to do this here. Anyone could suggest what to do? I'll give you some time to think about it, but those that did bearings should know some basic geometry, especially when it comes to two parallel lines. You should remember some basic geometry here that could help you. All right, I'll pause a bit, let people try to work it out. Did you get this far, Omara and Keandra?
No, sir.
All right, well, I'll pause a little bit, let you work it out. But this first question is not supposed to be hard. I'm just hoping that people can remember some of the basics of bearings. I'll put a little hint here on the side so that people can maybe you can figure out what to do. For those that were in the adult class earlier this morning, you might remember I had two parallel lines. If I draw a line between them, there was a relationship between this angle and that angle here. If this angle was 80, this angle was 100. Okay, so that is the hint that I would give you because both these angles should add up to 180. Okay, that's one hint I will give you. But your goal is to find out the full angle going around here and going around here. You want the full angle going around here. That's the bearing of B from F, the full angle going around there. All right. So it's a large angle, Omara, so it should be a large angle going around there. So it should be way more than 35. All right, 138 is the starting point, but that's not the bearing. So those that got 138 and 119, those are starting points to work out the bearing. Okay, but that is not the bearing. The bearing is the full circle in red going around from here to here. So you gotta figure out the proper bearing. The bearing is always the clockwise rotation. So 138 and 119 are starting points. All right, good job, Jayla. Good job, Jayla. All right, so Ramil, let me see if you can work it out too. But Jayla got 222. And that is the correct answer. Let me just clear this away. This was just a hint to help people. All right. Now, when you are working this question out, what you are going to do is this. You're going to tell yourself, remember the rule for bearings. These two angles here must be supplementary. So this angle and this angle here must add up to 180 degrees. So those two angles must add up to 180 degrees. So therefore, to work out this first angle here in this corner here, I'm going to put it in green.
Wait, sir, could say again which two angles add up to 180?
The two on the inside here. So this 42 and this angle that I'm going to draw in green must add up to 180. Okay? So
All right,
those
sir.
two must add up to 180. So my first set of working is going to be this. I am going to take 180. I'm going to subtract 42 degrees from it. And that is going to give me the 138. That would represent this angle here. Okay? Now, I should be able to figure out the answer right from this. I believe if you take 360, if you take 138 from 360, you should get the answer right away. So that's how I believe the others worked it out. So you take 360, which is a complete circle, minus that 138, and that should give you the full bearing of 222 degrees. But just in case you wanted to figure it out, if you wanted to figure out this angle up here, then this remaining angle here would have just been 119 degrees. We may need that later on, so I'll just put that in there to get that 190 degrees. That would be the 138 and 103. And you add them together and subtract from 360. But the correct answer is the 222 degrees. This is the correct answer for the bearing. All right. But this is what they wanted. That is the angle that is going all the way around here in red. All right. So 119 plus 103 is also that. So you can put R 119 plus 103 will also give you the 2. So both methods will work, but obviously the first one is a little bit easier. All right, next question. Calculate the distance BG. Give your answer to one decimal place. So BG, I'm going to call this common A. And from the time I call that common A, you all should know which rule to use, either sine rule or cosine rule. But tell me what's the appropriate rule for this. If you have the angle in the middle and you have the two sides, what rule would you use? Omara said cosine rule, and that is correct. So for those in the adult class who were there when they did cosine rule last week, this is the cosine rule to find this side here. Remember, the cosine rule is A squared equals B squared equals B squared plus C squared minus 2 times B times C times cosine of the angle in the middle, which is 103. All right, so that is the cosine rule, and I think Jella has the right answer. Okay, so let's plug in the values. I will call this B. I will call this C. and I will call this angle capital A. All right. So again, A squared is going to be equal to 32 squared plus 55 squared minus 2 times 32 times 55 times cosine of 103. Close the bracket twice if you have to. And most calculators can work this out in one go. But you have to, but let's just see what we get. I'm gonna work out these two here together. Work out these two together. That is 4. But Omara and Jella, you all are already correct. Okay, just letting you know. Just doing the full working for the benefit of others. And this part here becomes remember that because these are two minus signs, remember that it end up becoming a plus. So that is 4,840.828 to 3 decimal places. And then A will be the square root of that. So you have the square root that 4,000. So square root it. And your answer will be, if done correctly, 69.6 to 1 decimal place. Okay, so that is that. All right, so most of you got it correct. What is that? 60. All right, so just double check my answer. What went wrong there, Jella? You were close, but what went wrong? Omara, how come your
Sir, I
answer?
corrected myself.
Oh, okay. Ain't seen that from Keandra though. Where her answer is. All right, Keandra, I ain't seen that from you. Well, everyone here understands cosine rule. Remember, for those of the adults that I have here, remember the cosine rule. We started this the last class, and I gave you some videos to go and watch as well too on the cosine rule. So remember the cosine rule. Okay, so on the front of the paper, just like all the other formulas, so you can always go to the front page. And the cosine rule is somewhere is down here at the last formula that they give on the front page is the cosine rule. Okay, so if you forget it, it is on the front page. All right, so just bear that in mind. All right, next question. Calculate to the nearest degree the bearing of G from B. G from B. So from B would mean, if they said the bearing of G from B, then they want this of G from B. They want this angle here. But of course, we have one problem because this part in here is unknown. But we have enough information to solve it. Okay, so we just worked out what this side here was, and we said it was 69.6. So maybe, just maybe, we can use that to help us solve that side. So this is 69.6. And what rule? Omara says sine rule, which is correct. you want sine rule and you want to use the sine rule to find the missing angle. So I would need this. I would need this side here, the 55, and I will probably use the 103 and the 69.6. So remember the sine rule. Correct. So the sine rule would be sine of capital A on A, sine of capital A on A equals sine of capital B on B. Okay? So I always call the unknown angle capital A. The sine rule is in the front of the paper to the Quan, but they don't have it in this format. In the front of the paper, the Quan, they will have it inverted like this. So they will have A over sine A here equals B over sine B. Okay, but it is the same formula, the Quan. It's just that they will have the inverted one. I use this one here with the common letters for the sides, and I use the other one with the capital letters on top for the angles. Okay. All right. So if this is capital A, this is common A, and this will be my capital B. This will be my common B. So all you have to do is plug in the values here now, and you should be able to get the final answer for this problem. Okay, so sine. Let's work it out here quickly. I'm gonna maybe skip a step or two. So I will say sine A over the 55 kilometers is equal to sine 103 over the 69.6. Okay, now you guys work it out from there. So you guys work it out for me and let me know what you get. Remember, you have to add in the 42 at the end to get the full angle, the full bearing. Anyone has the answer? I started you off, so I'm hoping people can still solve it from here. Remember, you just have to cross multiply and work out what sine A is, then the inverse, and you get the angle and add on the 42 degrees to get the full angle. So that's the steps. I'm waiting on someone to give me the answer. Maybe Imitat or maybe Imitat or Daquan or Elliot, if possible. All right, so Ramil, we have an answer of 92.34. Does that coincide with what y'all have for this question? Yes or no? Just let me know if it does. Right, Ramil, you gotta be very careful because the question did say in its wording up here to the nearest degree. So you should report your answer as a whole number. Okay, so you should tell me 92. All right, so that is the answer. You don't want to lose any unnecessary marks. You gotta read the question carefully. So, the same way how you asked me that question, you always search the question and see what they want the answer to. Okay, because CSEC is very specific with how they want the answers, and most of the questions where you get decimals, they will tell you to the nearest degree or nearest whole number. Okay, so Amari, you got it? All right,
Yes.
cool. All right, so let me finish the working over here. So cross multiply, so sine A will be equal to sine 103 multiplied by the 55. So I cross multiply the 55 over on the right side over the 69.6, and that give me a, let me see what I get here. Let me just double check sine. So with my calculator, I can put it in one go. So I'll just put it as is. I'm not
So
going
I'm getting 0.77.
0 point. Give me 4 decimal places if you can, because the more decimal places in the next step, the more accurate the answer. At least at this stage, more decimal places, the better. 0 point. Is that so? Is that correct? Let me see what if that is it. So this is 0 point.
Well, it's 0.7699.
Okay,
So I
cool.
just did
So you are
0.77.
correct. 0.77 is correct. So sine A is 0.77. And now A, therefore, would be the inverse of this. So A would be sine inverse 0.77. And that would be
That would be 50.35.
50.35. Now, of course, since the question is saying nearest whole number, I'll probably just report it as 50. Okay, because 50 and the total angle or the bearing of G from B will be that 50 plus the 42, which is equal to the 92 as reported before degrees. Okay, so there you have it. It was not a hard bearing question, to be honest. There have been harder ones in the years gone by. It's just application of sine rule and cosine rule. All right, so we're soon wrapping up. Here we have a circle theorem question. Then we have the last matrices. Last question is the matrix transformation question. Let's do this circle theorem one as fast as possible. Again, my poor laptop is at 9%. Let me see if we can give it some more charge before it cuts out on me. All right, so do this bearing, do this circle theorem question. Let me see if you all can handle it. For those that know circle theorem, this should not be a difficult question. Feel free to put your answers in the chat below. All right, no, remove the question mark, Amara. The answer is 32. I know you got this covered. First answer is 32. But do you have to state the reason? So you can't just give me 32. Unfortunately, if it's worth with these questions, you have to state the reason behind it. So A, B, C. What was your reasoning, Omara? If you can remember the reason for it.
Angle. Wait, something about semicircle equals to 90 degrees.
The angle formed within a semicircle. Got me here smiling. At least you remember part of the rule. Got me here laughing. The angle within a semicircle is equal to 90 degrees. So that means this angle here is 90 degrees. All right. So therefore, ABC is simply taking 180 from a triangle and subtracting the 58 that they give us in the question and the 90 that we worked out just now using that rule. So just take away those two angles from 180 and the answer should be the 32 degrees. Okay, so for those who never did circle theorem, this might be a little new to you, but we can go through, it's something you have to learn for the exam. It's usually like a 6-mark or 7-mark question. So the rule that Omara used was angles formed in a semicircle are 90 degrees. Okay, just remember, if you have a circle and you have a diameter line going through it, any angle that you draw from that to that point will be 90 degrees. Okay, that is the rule here. Angles formed in semicircle equals to 90 degrees. All right, next one, CMB. I'm hoping maybe Jayla or Keandra or anyone else could answer the CMB. All right, CMB would be this angle here, CMB. All right, so see if you can figure out what that angle is. Might be tricky to figure it out. You get 122. Anyone else agrees with Omara? Omara, how did you get 122?
I subtract 58 from 180 because angles in a opposite angles in a it's got again a quad something equals to 180.
Help her, Kiandra. Was the rule? She got the right idea, but she didn't call the rule properly. You can help.
Opposite angles and a cyclic quadrilateral add up to 180.
Correct. Okay. Thank you very much, Kiandra. All right. Now this it might not look like it might not look like a quadrilateral to you, but if you check it carefully, it is a four-sided shape. This shape here is inside of a circle, so therefore it is a cyclic quadrilateral, and all the four corners are touching part of the circle. So yes, that rule applies. So if this angle here is 58, the angle that is opposite it, which is this angle down here. So that would be this angle down here. And the rule says the opposite angles of a cyclic quadrilateral must be equal to 180. So I will just say 180 minus the 58 degrees. All right. And as Omara said, the answer should be 122 degrees. All right. And Keandra's reasoning, opposite angles of a cyclic quadrilateral. Opposite. Instead of saying add up to 180, one word that can summarize that, you can use the word supplementary, Keandra, if you care to. But that word means adds up to 180, okay? All right, so opposite angles of a cyclic quadrilateral are supplementary. So this is 122 degrees. And this one here, we worked out before, was 32 degrees. All right, we're slowly but surely getting through with the question. Now the last one is NCM, which would be this angle here, NCM, that little small angle down there. I'm interested in hearing how you work out that angle down there. Now, you don't have, there are different ways of solving it. I think that there is an easy way of doing it, but the most hint I can tell you is that looks like a small triangle down there. All you need to do is find one more angle, and then you can find out that missing angle at C. All right. So if you think of this as a small triangle here, down here. This is a small triangle down here. See if you can figure out just one more angle of that triangle, and you have enough information to work out what C is. All right, so do that for me. I'm hoping to hear Jayla's voice, if she can answer this one for me.
Sir,
Yes.
the answer is 32.
Yes, it is. The answer is 32. All right. The answer is 32. All right, so let's have a look here at this working.
Wait, for your question, the answer is 32 for which one, sir?
This little angle, this angle here is what they're asking us to find. So it's 32 here. For the overall answer is this little angle down here. This is what they're asking us to find. So that's what she worked out. Okay, that's 32. Now, how I would have solved it, I don't know if you did it, Kendra, but I would have figured out what this angle here is. And then I would have used that information to figure out this little small triangle that I have down here. Okay, so that's what I would have done. So did you do that step, Kendra?
Yes, sir.
All right, so the first thing is this is a straight line. If this is 122, then the remaining angle here would have to be 58, which is 180 minus the 122, and that is 58 degrees. Okay, 58 degrees. All right, so if this is 58, then I could use that information and work out this triangle here. And remember, it is a small triangle. If this angle here is 58 and this is 90 degrees, then what I can do to work out that angle there now is just simply take add up the 58 and 90 and subtract from 180. So you say 180 subtract the 58 degrees plus the 90. All right, and I get the final answer of 32 degrees. Okay, now the reasoning. What reason would you put for this, Keandra? Is I can't think of any fancy circle theorem reason for this right now. What reason you would put for this?
Angles on a straight line equal to 180.
That's all I could think of. I don't know if when you finish this video and you check other people that solve it online, see if they have a different reason. But I can't think of anything else to put besides that. So I said angles in a straight line add up to 180. Angles in a straight line add to 180 degrees. All right, that's all I could put. Or if you don't want to use the straight line, you could say angles in a triangle. So you could replace the word straight line and change it with the word triangle, because we still use the triangle to solve it. Okay, so either or you could use the word triangle or you could use the word straight line. But that's how I was able to solve that. All right, we're on to the very last question. Amen. All right, now this is a matrices question, but it is also a transformation question. So most of you have done transformations before. Some of you have done matrices before. But now this topic is combining both of them together, and you have to know some specific details when it comes to solving these questions. Has anyone ever done matrices and transformations before? Yeah, raise your hand if you have or have not done it before. If you have done it before, then good. If you have not done it before, I will put a note on this in the classroom, either the fifth form classroom or the lessons classroom. But I'll put a note on this. This note is a note that myself and Miss Yard would have compiled in the last vacation to help people understand it. So you can look out for that note in the classroom. If you don't see it, you can always remind me to put it in. But let's look at the question here as is, and then we should be finished for the day. So a transformation T is defined by this matrix. So this matrix represents some transformation. Remember, transformation could be a movement, it could be a reflection, it could be a rotation or enlargement, but it didn't say what it represents. It just says a transformation. So 2 negative 1, 2, 0. Now, this point here, who's this person trying to join? Okay, Edwards. All right. So this point here is going to this point under this transformation T, which is given by this matrix here. Now, let us find the values of A and B. So, in other words, they're asking us to multiply the matrix with that point. That's all they're asking us to do. And of course, we represent the point as a vector. So we don't put it as 2, 3 horizontally. We put it as 2, 3 vertically. So this is how you will set up the question. You will say 2, negative 1, 2, 0 is going to multiply this point here, negative 2, 3. Okay? And now, anyone that knows matrix multiplication know it's done row by column. For those that don't know matrix multiplication, you just have to sit tight and watch as we go along. But do this multiplication for me quickly and tell me what you all get. Put it in the chat for me, and that will be the answers for A and B. Okay, so you're just taking the matrix and multiplying it by the point. All right. All right, so matrix multiplication. All right, Imhotep, you should definitely be able to get this out. I assume you did the matrices in full form, Imhotep. Correct me if I'm wrong. If not, I will put some resources there for you in the classroom. Goddard, your answer is not quite correct. Okay, wait, hold on, let me see. No, it's not correct yet, Goddard. Jayla, haven't heard you much for the afternoon, so tell me what you get for your multiplication here. Remember, matrix multiplication is row by column. So Jayla, tell me what you get.
-7 at the top and -4 at the bottom.
And that is correct. That is correct. So let's go through this here quickly. So again, row by column. So the 2, this 2 over here, this 2 is going to multiply this 2, this negative 2 first. So the first thing I will have is 2 by -2. Put them in brackets. Plus, and now this number will multiply this number row by column. So that would be -1 times 3. And I come down now, do the same process. This 2 will multiply this -2. So 2 by -2. And finally, we will have 0 by the 3. So bracket 0 multiplied by 3. And once you solve this, you should have what Jilla has. The answer should be -7, -4. Is that correct, Jilla? -7, -4.
Yes, sir.
All right. Now, and of course, you put it back in a coordinate form. So the coordinate form will be -7, comma, -4. And the answer for A would be the -7. And the answer for B would be the 4. And you've answered the first question. Okay? Now, please be careful with the solutions you see online because I saw a person work this out and they got the wrong answer. Now, in defense to that person, he did say that he was doing the solutions in a bit of a rush. So some things might be wrong, but I think the person had the wrong answer for this. But you have the correct answer there, Jalen. All right. Now, determine the transformation that maps A prime onto A. The transformation that would map A prime back onto A. So if this transformation, if this is the transformation that carried me from A to A prime, what would be the reverse transformation that will carry A prime onto A? Anyone could think of what you would do in matrices to go backwards. This is the one that carried me from A to A. How would I go backwards in matrices? Is there a way to do that? I'll give you a hint. The word begin with I.
Inverse.
The inverse, yes. You would need to find the inverse of that transformation matrix T. Okay, so that is the thing. Okay, we have to find the inverse of T. Now, if you've never found the inverse of a matrix before, if you've never done it before, then of course you may be lost. But if you have, find the inverse matrix for T. Okay, so find the inverse of this transformation matrix here. And I'll be back. Yes, Omara. Sorry, I couldn't see the chat while it was in full screen, so my apologies. All right, in the interest of time, let me just do this question here quickly. If you have the answer, that is good. But remember the inverse of a matrix, you have to first find the adjoint. In other words, you have to swap the matrix around. So remember, the original matrix here was 2, -1, 2, 0. So we're going to swap the terms around. We're going to put the 0 and the 2. So swap the first and last and change the sign of the second and third. So it goes from -1 to +1 and it goes to -2. We also have to find the determinant of the matrix. So remember the determinant. What will be the determinant of this matrix here? Remember the determinant is equal to A times D minus B times C. So you multiply the You multiply the 2 and the 0, A times D, and you minus the B times C, which is the negative 1 times the 2. If you don't know this process, it is something you have to learn. But anyway, the inverse of this matrix is 1 over 2 times 0, 1, negative 2, 2. And if you want it as fraction or as decimal, it would be 0 and then 1 over 2, or 0.5, negative 1, and 1. So this is the inverse. Either or is correct. I usually tell my students to stop here. Okay, but if you want to go further, this is also the final inverse. Some students or some textbooks prefer to go the final step and give it like this. Okay, but that is the inverse. Now correct me, Jayla, did you all get that, or y'all didn't get
Yeah,
that?
I got that, sir.
You got that? All right, good. All right, good. Now, the next question. Find the single matrix that represents. So this is another question. It gives you another transformation P, which is 0, 1, 1, negative 2. Find the single matrix that represents the combination or the combined transformation of T and P. So just to jog your memory, T, if you go back one slide, T was 2, negative 1, 2, and 0. That was T. Now, whenever you are combining matrices, if it says the matrix T followed by P, now this is where people make the mistake. Now, I do have this in my notes that I'm going to post in the classroom, but when it says T followed by P, when you're doing the calculations, you put the P matrix on the left and the T matrix on the right. It sounds counterintuitive, but that's just how it is done. So you put the P matrix first and the T matrix last. That is just how it is with matrices. That is in my notes. So just please remember that when you are working it out. So you put P, so the P matrix is going to be 0, 1, 1, negative 2. And you're going to multiply that with the T matrix, which is 2, negative 1, 2, and 0. So this is a matrix multiplication question. Again, matrix multiplication is row by column. So if you've never done matrix multiplication before, you might be a bit lost. But for those who have, they should be able to do it. Okay, so let me just bring it across some more. All right, let's do this multiplication quickly. I have to pretty much go soon from now, so I think I had enough online class for one day, so I can go through this question quickly. So let's do row by column. Remember, row by column. So Goddard, don't make no mistakes here. So it is 0, 0 by 2 plus 1 by 2. Row by column, 0 by 2, 1 by 2. And then you leave out a space. You do the same thing again to the next column. 0 by negative 1 plus 1 by 0. You come down and do the same thing again. So it's now 1 by 2 plus, actually that should be, 1 by 2 plus negative 2 by 2. Come across now. And that is 1 by negative 1 plus negative 2 by 0. All right, so for those who never did matrices before, it looks complicated, but when you get the hang of it, it really isn't. So what is the matrix that is the combination of these two transformations? So it's just a matrix multiplication question, but you need... All right, Goddard, have a good evening. I gotta leave soon too, so I'm looking to finish just now. So what is the final answer here for this combined transformation? All right, hit me with the answer quickly so I can put it on the board. Let me see, Kendra, what did you get? Jayla? Yeah, Jayla, you were talking, so you continued in, Jayla.
20 negative 2 and negative 1.
That is correct. 20, 20, negative 2, negative 1 is correct. So 20, negative 2, and negative 1 is the combined transformation. So the only thing to remember is that you put the second one first and the first one last. That's the weirdness of this transformation thing. So when you're combining two matrix transformations, the last transformation goes on the left and the first transformation goes on the right. So that's the only thing that you have to remember when it comes to these transformations. Now, if it says hence means you have to use the previous answer to work out this thing. So what is 1/4 under this transformation? It means you take your answer 20, negative 2, 1, negative 1, and multiply by the 0.14. So you put it as a vector 1/4. And I'm going to do this really quickly because time. 2 times 1 plus 0 times 4, and negative 2 times 1 plus negative 1 times 4. Hope I made the mistakes. Cool. Everything looks good. And the answer is 2, negative 6. But it is just normal matrix multiplication. You just have to know what to do. But this is the answer here for B. All right, so I have to move on to the last question now. So the last question, amen, we are there now. It is this vector question, and it seems like a fairly straightforward vector question. I hope so. Fingers crossed. Actually, it is. So let's look at this vector question here very quickly. So you have this here, not drawn to scale, quadrilateral A, B, C, D. They give you AB as M, they give you DC as 3M, and AD as N. And they have the arrows to show the direction that they mean. All right, so with this question here, now, so let's see what the answers will be for AB and DC. So let's see. Complete the statement below about the properties of the following vectors. What can you say by just looking at the diagram about AC and DC? One word.
Parallel.
Yes, please. They are parallel. And AB is how many times CD? Don't mind I give you a big space. It's a small word. AB is how many times DC? I never believe I would never believe I would see a vector question so easy in my life. How many times? Someone said the answer just now. I didn't hear. 3? Yes, 3 times. Never saw a vector question so easy in my life. All right. Easiest 2 marks ever. Now, this is probably the challenging part. I can't say, but we have to represent BC in terms of small m and small n. So how will I get from B to C? Can someone tell me if I am standing up here and I can't go this road. This road here block off. Police line don't cross. I can't go this road. How will I get from B to C going another route? Can someone tell me how I can do that? How can I get from B to C? And tell me in terms of M and N. So walk me through. I want someone to unmute their mic and give me this walkthrough very quickly. How would you get from B to C going the long route?
Negative n.
All right, good. That sounds like Omara.
Yes, sir.
All right, good. So negative M
Plus
uh-huh,
n.
plus N plus,
3n.
and now simplify it if you can, a little smaller.
N plus 2m.
And that is the answer. Thank you, ladies. Excellent work.
So
Is the
question.
easiest vector question in life. Yes, Imhotep?
So you got any material or like videos you could send on vectors? Because I can't remember doing vectors in school.
Or I have recordings that I can post in the classroom. And I have the notes so I can put them there for you. Okay, but just remind me via email and I'll
Thanks,
put
sir.
it. Probably not today because after I do this class, I go in the beach hard and relax myself. Because I had there's the second 4 hour class I have for the day, so I go in and
No
relax
problem,
myself
sir.
for this. But send me an email and I would remember. All right, so now the last question. The last question on this test. L is the midpoint of CD. So L is this makeup midpoint that I have here. This means half of CD or half of DC, whichever way you want to look at it. Find BL in terms of M and N. So I want to know who can do this for me. Maybe tell me verbally how you would do it. And you can possibly use a previous answer to help you. Anyone wants to give it a go verbally? Maybe. Yes. Who's going to give it a try?
Sir, I kind of forget, but I know you gotta use over. You could use over the formula we find for BC, which is n plus 2n.
You could use that, which is what I have in my notes here.
Right, and then the distance from C to L. Wait, I think.
C to L. Now, remember, there's some formula I gave you all before. So remember, if you want to work out B to L, remember, I think I keep on saying this over and over. So if you want to work out B, wrong color, B to L, I could split this into two vectors, I can say B to L is B to C first, and then it would be C to L. Remember, go to the bus stop, and then from the bus stop, you go to your destination. So B to L is B to C, and then C to L. If y'all remember Mr. Reddy's what's it called? His rhyme for it. But this is a way you can look at it. B to L is B to C and C to L. We worked out B to C from before. So you will be correct, Omara, in just writing back the previous answer for this part. N plus 2n. But what now would be the CL part? Could you tell me what anyone could tell me what was CL be?
Negative 3 over 2.
You gotta give me a letter with it afterwards. You're correct, but you gotta give me a letter with it.
Negative 3 over 2 n.
M as in mouse,
Yes, sir.
and that is correct. Negative 3 over 2 M. All right, so remember CD, L is the midpoint of CD. So whatever CD was 3. And if it's the midpoint, I will have to divide CD, I will have to divide that 3M by 2. And because I'm going the opposite direction, I have to change the sign to negative. Now help me simplify this. Help me simplify this now as the one nice problem. I got too many M's. Let's simplify this. Was 2 take away 3 over 2. 2 take away 3 over 2. I got the N will come back, but I just want to know what's the last thing to write down. These two got simplify. Just use your calculators. 2 take away 3 over 2. A half M. All right, people, this is the end of the exam. And it was long, but it was only long because we were explaining as we were going along. So, when you get around to doing the exam itself, hopefully you will be a lot faster. As you practice more and more, you get better. Remember, any topic we went through, just know that you don't understand. Chances are you either need a refresher or you need to go and learn that topic. Circle theorem for my adults, they got to go do that now. For Omara and you, Jayla and company, you may want to go and learn the matrix transformations. I'll put those notes in the classroom for you between now and tomorrow. Imhotep, vectors, you said you need help with vectors. So I'll put some of the recordings as well as resources for you on vectors, Imhotep.
Thanks, sir.
And that's about it. I think I started with about 10, 15 people. We end up with 9, but that's all. People had to go, but we were here. We thank you for sticking true, and we finished one complete paper. And of course, you can always check the solutions again online to verify. But we finished one paper. So good evening, everyone, and chances are I will not be doing this anytime soon. But if I do another paper, I'll probably do a recording of myself and I'll just put it on YouTube. I probably will not have a live session here where I go back and forth with people because obviously this takes up a long time.